Hello and welcome to the University of Pittsburgh's Health and Explainable AI, Pitt HexAI podcast series. Pitt HexAI is a research laboratory at the University of Pittsburgh School of Health and Rehabilitation Sciences, Department of Health Information Management. Headed by Ahmad Tafti, the lab cultivates extramural collaborations with other academic institutions, both nationally and internationally, through its research and educational contributions and this podcast series.
Hello, and welcome back to Pitt's Health and Explainable AI podcast. I am Mythili Tirumalasetty, a student at the University of Pittsburgh. Every month, I am going to guest host a special interview with a student like me who is also pursuing studies or research in the field of health informatics and artificial intelligence. Join me as we get to know more about their interests and their work. Today, we are going to get to know about Davina Zamanzadeh from UCLA. Hello, Davina. Welcome to our podcast. To get us started, would you like to introduce yourself?
Hi, Mythili. My name is Davina Zamanzadeh. I'm a fifth-year PhD student at UCLA in the computer science department. I have a background in computer science. I did my undergraduate studies at UC Santa Barbara, and then I went straight into my PhD at UCLA under Drs. Majid Sarafzadeh and Dr. Alex Bowie.
That's interesting, Davina. What got you actually interested in health informatics and artificial intelligence?
So when I was little, thought I was going to be a doctor. And then in high school, I took biology and realized I couldn't do it. I could do it, I just didn't like it. And I knew that was going to be my future for a long time before I was ever actually doing any sort of patient care that I envisioned myself with. And I said, all right, hard pass. I need to find something else. And I got into computer science. My dad actually kind of inceptioned me into it. He kind of talked me into taking a class my freshman year of high school. During the summer, I was doing nothing. He's like, why not take this computer science class? And I ended up taking that class and I enjoyed programming. So I just followed that. When it came time to apply to college, then it was a no-brainer. Of course, it's computer science. And as I was going through my undergraduate career, I had to think, all right, what's the next step? And I always wanted to wrap back to my interest in health and medicine. And personally, I have Crohn's disease, which is a chronic inflammatory disease. I've had it since I was 8. And with the skills I had learned from my machine learning and AI courses, I thought, hey, isn't this the best time to try to apply it? And my thought process was, if I don't do it now, I'm never going to do it. And I'd rather much try it and fail than not try it and just be wondering for the rest of my life. And so, yeah, that was it. I ended up just pursuing that idea.
I'm sorry that you had that condition, but I think as a field, we're glad that you have, tried this field out, which is great. So can I know what exactly inspired you in doing the current research in the field?
Yeah. So again, my initial idea was, I have Crohn's disease. I did my best to give back as much as I possibly could as a patient. So any research study they were doing, they needed to do more blood draws, whatever, I always approved. I always signed up. If there was a student that was shadowing, I would let them in the room, all that sort of thing. And when it came time to think of, well, now I have these skills, what if I could give back in that way? And so I actually applied for a PhD with a specific idea in mind so I'm a patient at Cedars-Sinai, and I knew from their newsletters that they have a very large database, particularly of IBD patients, but again, beyond that. But I was just focusing on IBD, irritable bowel disease. And I said, this is a great opportunity. I have connections here. Maybe I can actually make something of this. And because I'm at UCLA, I said, hey, there's probably a connection there. So, I enrolled. I wanted to apply machine learning to like Crohn's databases or IBD databases. And so I talked to my advisor, and then I talked to my gastroenterologist, and I said, hey, do you know of any, can you connect me to the guy that's running this research project? And he said, yeah, sure. I talked to my advisor. I said, hey, I have this idea in mind. Can I pursue this? He said, yes, that sounds great. Go ahead. And so I got a meeting with the research group, and I pitched myself, I pitched my lab, I pitched the ideas I had, and they said, okay, sounds cool. But we're going to give you this other data set to see like what you can do. And I spent, I think, like a year on that project. And then from there, it was just kind of like I was already in the area, and I ended up just working on a bunch of other stuff.
So, Davina, tell us about your current work, your previous projects, and the projects you're doing right now. And is there anything interesting that you've discovered that you'd like to share?
Yeah. So though I started with that initial project, it unfortunately didn't really pan. And I think, you make plans and the universe laughs. That's kind of how it generally goes. And right now, all my projects are currently in nephrology, actually. So from there, I ended up joining what is called the Cure CKD project with a group of nephrologists at UCLA Health. I work with wonderful nephrologists. They've really helped shape my career from my first year. And in that project, we are doing a lot of things, actually. We have a very, very large database of patients with chronic kidney disease and or just AKI or acute kidney injury. And with that, originally, the focus for me at least was with chronic kidney disease, you have kind of what you measure is the eGFR, the estimated glomerular filtration rate. I hope I said that right. And that's kind of like a measure of your kidney function. And when you have chronic kidney disease, your kidneys are slowly declining. And so your eGFR is going to decline at some rate. But there's some subpopulation for which that your kidneys just decline at a much faster rate, which we call rapid kidney function decline, or just rapid decline for short. And the idea is we wanted to be able to predict patients who would have rapid decline before they had it. And then hopefully, maybe in the future, if we do a good job of that, it would substantiate the idea that we could maybe start a study to pull these patients in and do preventative work on them and see if we could prevent rapid decline instead of hindsight trying to manage the disease. So that's where it started. And while I was working on that, a very large real-world clinical database of, I think, like over 1 million patients, there was a lot of missing values. And more importantly, missing values for important features or variables. So like, we know that blood pressure is a highly important factor, and we were missing like 60% of that. And so basically that kind of just not shoehorned me, but the natural conclusion for me was starting to look at estimating missing values. And that's kind of what launched me into what is my thesis now, which is using a particular kind of deep learning model, like autoencoders in particular, for imputation or the estimation of missing values in large data sets. And that's how that started from that first project. And I've had the pleasure of working on, I think, a smattering of a bunch of different projects in different areas. But for the most part, I ended up just staying in nephrology. Another project I'm also currently working on is with another nephrologist at UCLA Health. And with that nephrologist, Dr. Kurtz, we are looking at a specific kind of dialysis called continuous renal replacement therapy. And so if you're familiar with regular hemodialysis, we see it on the California ballot every cycle. You're on it for a few hours, multiple times a week, and that itself is time intensive. But the volume of blood in and out is really high. And if you're really sick and in the hospital, and what we say hemodynamically unstable, so your blood pressure is either really low or really high, you can't tolerate hemodialysis, so they'll put you on continuous renal replacement therapy, or CRRT. Now, this is an active project right now. We are planning a paper for Nature. We have data from UCLA Health and Cedars-Sinai, which is amazing. And with that one, we are trying to improve the clinical decision-making accuracy with a predictive model. And stuff that I find interesting in hindsight, because I guess I've been doing this for like 4.5 years now. A big lesson I learned was when you're working at an intersection, I think most people have the intuition that, yes, the domain expert is very important. And understanding each other's language is very important. So most of our processes, the first thing is we sit down and we say, this is what we do. This is how we talk about things. This is our workflow. All right, can you tell us about this specific problem? Can you give us kind of context and understanding? But the thing that I was surprised to find out later, which was what I learned with my first project, was in the intersection, the interest has to come from the clinical and healthcare side. Otherwise, it's me running around with a hammer and, maybe someone doesn't want me to do anything on their, like construction site for the case of the analogy. But the thing is, even if you come up with a really cool idea, if it is not active interest from the clinical side, if it's not born from that side, I believe it's very difficult to see that project through. And I think for a good reason, which is everyone is busy. Everyone is doing like the utmost that they can during their job hours. And if you want to set aside time for a new project, it has to be like of utmost clinical use, and it has to be something you're interested in. And so without that, you're not really going to get the resources you need. And so it can be really hard to push a project forward like that. And even if, it's the fault of no one, it's just a matter of like normal management, right? Like I didn't think of it like that. Like came with this thing. It's not a high priority. And of course, it's not going to be met with the same time and intention that I came at it with. And so I learned that thankfully early on. And so from there on, most of my projects were, a clinician or someone in health would come to us, said, hey, I want to work on this. Can you help me? And then it'd be from our side, yes, that sounds interesting. Yes, it sounds like we can actually make a difference here. All right, yes, we'll work with you. And I really want to underscore that first project, I don't want to paint anyone in a bad light, but just like a natural consequence and something that I didn't understand and was like overly optimistic about. Other things that I've learned that are interesting is, the nephrologists I've worked with on the QCKD project, like Dr. Duro, Dr. Nicholas, we have a whole slew, and also Dr. Kurtz on the CRT project. They're very smart people, and I think I was surprised at how quickly and intuitively they understood the computational side of things. And I found mentors and like role models in the way I wasn't expecting to. And I think that was valuable And I've learned a lot of things from people like outside of my direct purview and my domain. And I think the interesting thing about working is in this intersection is you have an access to such a wide range of experts and professionals, because it's not just clinicians, it's people in public health, it's nurses, it's people that create, health programs, they manage directives. There's like a lot of different things that I didn't know about before that it really opened my eyes. And I think that's really interesting.
I totally hear you, Davina, because it's a collaborative course our field is. So it's very important for us to accommodate each other's communicative languages. Like you might be speaking in a programming language, but the physician might be speaking in a medical terminology, which you might not understand. It's not layman to you. So yeah, I totally hear what you're saying. And it's really interesting how you navigated your way through all of this. I just am interested to know, what do you think that this field is directed towards, where it is headed, and what do you like to see in this field? Like, where do you see it going?
Yeah, I think that's kind of a hard question to answer specifically from my point of view. The thing that I see currently is that there's like a decent gap between here's stuff we are researching, and the research needs to take time. You need to do it right. It needs to be peer reviewed, and then being able to deploy. And so you see, or at least I see, a slew of things kind of from the pipeline of academia. You do research, and then, you publish on it, so on and so forth, until, the doctor that came to us said, yes, I want to deploy this in my actual practice. But then there is like a growing number of health startups that I think are born out of the people in academia. I think it is a growing field. I think it's growing a lot. I think this wouldn't have happened without signing EHR into law and having a lot of hospital systems convert. Like, this is the best time to be doing it, right? Because now we have not only the hardware, the storage, but also the legislation in our favor, which we didn't have before. It's not that long ago, right? It was signed in by Obama. So I don't remember, I think it was like 2013, something like that. I have to check the date, but it hasn't been that many years since we've had electronic health records, which also has its own problems. And so I think as we solve those problems, get over those hurdles, and as more hospitals adopt, it's just momentum towards a growing field. I do think there are limitations for good reason. One, there are limitations legislatively, but they're also aligned with like the moral and ethical reasons, which is you need to be very sure and very careful. So for privacy, security, but also correctness, technical validity, and also, is what you're doing like a positive impact? I think occasionally in tech, people can kind of get like, what if we did this? What if we did this? And there's not much recourse for like, all right, so what are you doing to mitigate like any potential, bad outcomes? And we see that right now, right? Like, we have ChatGPT, we have chatbots, we have DALL-E, we have Stable Diffusion, we have deepfakes. And I'm all for the democratization of these tools. It's very important. And I think, ChatGPT and a lot of these newer, I want to say, projects and groups and organizations around these tools, I think are doing a decent job, right? Like, ChatGPT had very strong locks on it. It was very well thought through. But we don't see that all the time in tech. And it's pretty strong requirement in health. And so what you can and cannot do is very, very stringent. And I think that just poses a bit of a limitation, though I believe it's absolutely necessary.
That sounds spot on for me because navigating through the way of right and wrong and finally making a change, especially in the field of healthcare, is all this field is headed towards. So that's really something that's really important. And so that brings to my next question. On our podcast, we usually ask our guests for the thoughts on explainable AI. What's your view on that subject?
So I think, again, motivated by the area we're in, another problem that I didn't say before from the previous question about like where I see this field going is adoption, adopting tools and stuff like that. And also kind of philosophy of, will AI replace or is AI assisted? Now, personally, I believe its only role is assistive. It should only ever be assistive. I've met multiple people from both the technical and clinical side that have completely differing views on all sides of the spectrum. And the thing with adoption, whether or not it's a tool to replace or a tool to assist, the problem of adoption is, or I guess a burden, or not burden, I guess responsibility is the word I want. The responsibility of adoption is you need to engender trust. If people don't trust your tool or your work, it will not be adopted. Well, it should not be adopted, but it will not. You will get nowhere, even if you did everything right. And I think to promote trust, you need transparency. People are scared of what they don't understand. And so I think explainability is kind of that solution where you have a limitation, which is, we have really powerful methods that we don't 100% understand out the gate. And there's an opportunity to address that, to promote that trust and transparency. So I think explainability is necessary for adoption, especially in any intersectional domain, and particularly especially in medical domain, where the decision is not a light one. It's people's quality of lives and lives actually on the line. And so you need to approach that with great care. And so it really matters to understand how the model is making a decision, not only to promote trust, but also to catch any bias, to catch patterns that you weren't expecting that might not be biased, that might actually be a signal that you now need to pay attention to. And I think that thankfully, the machine learning and AI community has, I think, managed to gather and put time and resources and effort and build a community in explainable AI. And there's just like more and more tools that we're able to use to inspect models and why they made the predictions that they did in a nice visual way. Like there's SHAP, there's Mythili, there's Lime, there's so many more out there as well. So I think I'm very thankful for the people that have dedicated their time towards that.
Yes, I'm thankful for that too. So, Davina, we actually ask our featured guests to offer students a research project idea. Would you like to add any ideas to our list, or in reverse, what kind of a lab would you love to see in a university launch or a lab-affiliated project?
Yeah, I'm not sure. I think with project ideas, I'm so entrenched in like the world that I see that instead of being like a high level, wouldn't this be super cool? It's kind of like, who can help me with what I'm currently working on?
That's where the inspiration births from. So that's totally cool.
Yeah, I think I'd say open source community in scientific computing. So I had the pleasure of going to the SciPy conference last year, Scientific Python. So not the SciPy package, but the Scientific Python community. And I worked with Brianna Schuten, who is in the Netherlands, on amputation, which is the process of introducing missingness instead of fixing it, to then help you kind of analyze, characterize, understand missingness in so many different scenarios. And so I worked with her to port her methodology over to Python, and went and presented, and I met just such a wonderful community of people. And I think there are a lot of interesting projects going on there. And it's a very nice and welcoming community. So, pushing not only the amputation project, which would be helpful, paying more attention to missingness in general, but also just open source. There's a lot of awesome tools in the open source community that not only are driven by large companies like Facebook and Microsoft, and a lot of them thankfully make their projects open source, and they actually interact decently well with the community. But there are a lot of projects that aren't run by large companies that are really useful, that I've found in kind of my journey. I use Guild AI for experiment tracking, and the dev for that is super responsive and a really smart guy. And I've also found there's another experiment tracker / visualization tool called AIM, which is very new. And I've been talking and working with them and building out new tools. And it's just really exciting to kind of sit there and be like, I need this in my workflow. And they're like, oh, well, that's on our roadmap. And then I could be like, well, if you need help, I'm right here. And I think stuff like that really helps the community as a whole. Right now you have tools. You don't have to rebuild the wheel. It's made in a way that works for you. It's likely going to work for a lot of other people as well. I don't know how I would marry open source with healthcare. I guess my perspective is a much more computational one. But I think giving people the time and day to actually interact with that community is very valuable. And I'm unfortunately the kind of person that I have only these things on my plate, and I can't attend a bunch of interesting meetings and stuff like that. And being able to have the time to sit and just be like, this is really cool. It's not directly my work, but it's really enriching and useful to spend time on, which I previously wasn't really doing.
What's your take on synthetic data? And would you like to elaborate a little more on the field of missing data? It's a subject that students might find really interesting.
Synthetic data would be a great addition. It's would be its own thesis, in the sense that think about all the things you need to do to generate synthetic data so that it's even useful from a clinical point of view, right? If it's too much of a toy, then anyone you talk to will be like, then why does this matter to me? I'm never going to use this. The field of missing data, I think, is starting to push the ball a little bit. So there's kind of this fundamental work by, did I forget his name? Rubin, I think, or Little. Ooh, I should know this. I believe it's Rubin. It's old now, from 70s or earlier. My numbers are all wrong. I used to know this. But at the time, they came up with this paradigm of mechanisms for missingness. And they came up with 3, which is missing at random, missing not at random, missing completely at random. And the words are kind of confusing because missing at random is not actually missing at random, intuitively. Missing completely at random means that, whatever you're looking at, there's no other feature or variable, observed or unobserved, that explains the pattern for why this feature itself is missing. Missing at random means there is some observed feature that explains the missingness of your semi-observed feature with missing values. And then missing not at random means that either it's missing because of the values itself, or there's some unobserved feature that explains it. And the more I think about it, the more you realize how wide that is. And there's a lot of interesting work on this. So there's a researcher at UCLA called Judea Pearl. He's very big for his causality work. And him and his students have looked at this paradigm and tried to characterize these mechanisms in more detail. And I think more specifically, there's one work that looks at when can you actually reliably recover missing values for these different mechanisms. And they showed that, they were able to characterize it more specifically. But I think it kind of begged the question of, is this paradigm that accurate? Or is it holding us back? And I think that to some degree, yeah, it's really wide. It's the best that we've got, and it's useful for what we have. And we can make guarantees for missing at random, specifically for certain like imputation methods from the statistical realm, like mice. But beyond that, it ends up looking really limited in such a complex world, because missingness is, I think, as complex as the data itself, or the data themselves. I don't know what the plural for that would be. But I think hopefully more people will start being like, wait, no, this is not just like I Google, how do I impute? And then I plug in scikit-learn simple imputer and I leave it alone there. Hopefully more people, kind of the way we've spent time on explainability, kind of start paying attention to missingness. And hopefully maybe someone smarter than I am will come up with a more insightful paradigm for understanding missingness. But the idea is, with my imputation work and my work with Rhian Schutten, is we will be able to characterize and understand this realm a little more, and characterize solutions for imputation a little more. Hopefully that insight will lead us to the next thing.
Davina, do you have any thoughts on ChatGPT, which is very happening right now?
Yeah, so I used to be very strongly in the camp that AI and ML is dumb. It can do very specific things really well, but the idea that AI will replace us, or wow, it's so good on this such broad stroke task, I was very like, no, that's never going to happen. And I think ChatGPT has kind of provided a strong counter, not to AI will become sentient, but the idea that it can feel human, and do really well on such a broad stroke task. Now, I think ChatGPT is just text generation. Sometimes it feels like a really smart amalgamation of like the top Google searches, where it kind of puts together information in a useful contextual way. I think that's still really impressive. And I think that it is very useful only if you know a good chunk about what you are asking it. And I think this is kind of the advice that's going out around now by most experts, which is, I think they're calling it hallucinations now, which is the model will confidently tell you the incorrect information. And I know sometimes I think even for the chatbots now, if you correct them, they'll be like, no, you're wrong. But with that comes some danger, right? So I think you have to know enough to be like, all right, this is going to help me with something, but I'm able to be like, yeah, that's wrong, but I'm going to take the parts that I know are correct. And so I think stuff like programming is really helpful, but you kind of already have to know like either the framework that you're asking it about or the programming language you're asking it about. A lot of people are using it for like cover letters. I think it's a helpful brainstorming tool where sometimes it can be really hard to just get words down on a page. And I think it kind of alleviates that initial burden of here's a blank page, like the SpongeBob meme, it's just the in the corner. You're staring at a blank page. I think it kind of alleviates the burden of like, I just need to get content down. It doesn't matter if it's terrible. I can edit it, but it can be really hard sometimes to put just put things down on paper. I think this is really helpful for that. I think there's a lot of other things that I just haven't seen it used for, but people have been really creative with it. I think it sets a really good precedent that they've made it open. I think it's nice that they're kind of transitioning to like a premium version and still leaving some of it publicly available. I think part of what I was scared of was this kind of trend of people make things publicly available so they get all this like reinforcement and training data from it. And then they're like, haha, too bad. You can't use this anymore. Now, I still don't know if that might be the future for it. Hopefully not. But I think it so far is a nice precedent that a lot of people can interact with it. And people have been very creative with it. And people are looking at its applications for like healthcare and medical. I don't think it's directly applicable. I think they've done a few studies. They found that it can like barely pass the medical board exam, which is kind of crazy. I think to some degree it's kind of like impressive knowledge regurgitation, but outside of that, I think you can get really creative, but I'm not quite sure, again, how immediate that futuristic idea looks like of what if you had, GPT bot answer medical questions when you have this like large problem of quote unquote hallucination on your hands. So I think people will start to pave the way there, but I think it'll take some time.
Well, that's interesting. Thank you for giving our viewers a lot of interesting ideas to explore. That's amazing. Would you like to give any motivational insight to your fellow students?
I think I can give it from the perspective of a PhD student. I think an important thing to me is when I started my PhD, I did it with a lot of intention. And I kind of made boundaries for myself and specific rules, which was if I was miserable, then I wouldn't just stick with it just to stick with it. And another was the idea that I chose the PhD. I think for most of our lives, going to college is not required. Before, I don't know how many decades ago now, but before college was kind of like a nice extra, and then doing even higher education was even more rare. I think people going into graduate school is becoming more and more common. I think the ceiling is slowly rising, or not slowly, but I think we feel compelled / required to at least get to college. And you spend 21 years of your life doing something you are compelled to do. And then all of a sudden, it's really unstructured. You can do whatever. There is nothing you are compelled to do. You just have to, either feed yourself, put a roof over your head, pay your phone bill, pay your insurance, so on and so forth. What you do outside of that, there is no structure. There is no structure at all. And that can be really hard. And when you go to graduate school, it kind of feels like one more thing you are now compelled to do, which is to stay in it. But something I promised myself, which I think was very valuable and something I followed through on, was treating it like a job. Is I chose to take this job on. My job is to learn. My job is to do research. And because I chose to be there, I can also choose to walk away. And I think for some people, maybe that line of thought's not super helpful. But for me, like having the option to walk and knowing that it's like literally my choice, my freedom, my intention, I was super helpful because the PhD is challenging. I mean, technically, sure. I think more so from like an emotional and mental standpoint where you are managing yourself and there's no one there standing over you saying, hey, are you burnt out? Or, hey, you're not making that much progress. It's all on you to manage your time, ask for resources. And you can get stuck for a really long time, and it can be really hard, and it can feel unfulfilling for a while. And knowing that, hey, like, I chose this. I don't have to be here. And being able to be like, no, I want to be here, really helped me get through all the kind of sluggish phases, or where I was feeling inadequate and dumb, or I wasn't making any progress and I felt like, well, like, why am I here? It was really helpful to go back and be like, well, this is why I'm here, and I actually do enjoy this, even though right now I might be struggling. Or, this is not what I had in mind. I should change where I'm at right now. And if nothing changes, then okay, like maybe a bigger change is necessary.
I really admire the zeal of yours to keep your inspiration alive. That's really cool of you. Thanks again, Davina, for speaking with us today. That's really cool. Thank you.
Thanks everyone for tuning in and for following the show. And a special thanks to the University of Pittsburgh School of Health and Rehabilitation Sciences, Department of Health Information Management, and to Pitt's Health and Explainable AI Research Laboratory for launching this podcast. We'll see you next month.